Hello everyone, welcome to today's Vitodens 100 B1HA B1KA product overview webinar. My name is Miranda Getling and I'm the Academy Manager here at Viessmann. I wanted to take this opportunity to say thank you for attending today. We appreciate you taking the time to attend this webinar despite what we are all going through. Today, your instructor will be Jay Sheldon. Jay has been with Viessmann for the last 5 years. The first 3 years he was a member of the Technical Service Department before moving into his current role as the Academy Training Instructor. Jay has a master license, has been in the heating and cooling industry for the past 30 years, including holding job titles as General Manager, Service Manager, and owning his own company for 14 years. Jay is a United States Army vet and loves to spend time with his wife, 2 children, and 2 grandsons. Just a few housekeeping items before we begin. Everyone will stay muted throughout the webinar. However, at the bottom of your screen, you will see a Q&A button. If you have any questions, pop them in here. Jay will be stopping halfway through the presentation, as well at the end to answer any questions that have been submitted. We will be recording the webinar and posting this in our video library available on the Academy website, the same one you went to register for this webinar. Once you are in the video library, you will select the recorded webinar section, and then you will have to hit the Discover More button for the videos to populate. This should be up within the next week or so, therefore you will have the opportunity to go back and rewatch the webinar at any time. With that being said, let's begin. Here's Jay Sheldon.
Thank you, Miranda, and welcome everybody to the Vitodens 100 B1KA and HA class for an overview today. Before we get started, just to set a few things straight, I did desanitize my mic and everything before I started. And all joking aside, really, hopefully this will all end soon and we can all get to our normal lives and you can actually come here and do some real hands-on training at our facility. We have a wonderful facility that has been totally changed in the last couple of years to be more for hands-on training. With that being said, we're going to have a few couple of quick questions for you. Just a couple of quick questionnaires, just so I know who's coming to the class and what we got going on. So the first questionnaire. All right, so that's the first questionnaire. And we can get the results on that so I can kind of see if anybody's ever worked or serviced on one or even seen one. As they populate. There we go. All right, so we have a few people that have never installed them or serviced them. So that's good. That it's a good time to come and see it. Gives you some time to see what our product's like, and hopefully by the end of this webinar, we can change your mind and see how you like our product. With that being said, we'll go on to the next questionnaire. I'm glad my camera is not hooked up, so you can not see me my head bob into the music. All right. Huh, that's pretty surprising. So it'd be nice to see you come to our hands-on training. And by the way, we have these 100s. We have actually four HAs and 4KA models set up so you can come in and learn how to do hands-on training. We have installation classes, service classes on how to service and maintain them, as well as we have our troubleshooting class as well, where we can actually create faults on the boilers, and you can troubleshoot as well. And some of the troubleshooting techniques that you learn will help you with other people's boilers as well. So it's a good training class. It's a lot of hands-on, which is really new for us here. So with that being said, I'd just like to go over a quick little presentation of the company itself, and just to give you an idea of who we are, where we come from, and what we do. So we are a family-owned company. Matter of fact, Maximilian, the son of the former owner, took over last year. I'm sorry, and he is now the fourth generation. He actually took over about 12,500 employees, and he's about 30 years old. We are, like I said, a family-owned company. Here in the picture that you see here at the bottom here, you're looking at our warehouse in Allendorf, Germany, which provides us with all these wall-hung gas boilers, and this is where they're all manufactured. As you can see, there's a full-size scale train here. So that's giving you an idea of how the size of and scale of this building. It's actually this size, and it goes down to size 6 stories. And it's all animated. So everything gets picked and pulled with the machinery. As well as if you look at this entire building here, you can see full trucks here. So they do move a lot of heating systems around throughout all over the world. This building is about a mile long and about 3/4 miles long, and it's 100% off the grid. That's meaning that they produce all their own electricity, all their own natural fuels. They do that in many different ways. They have biomass wood chip boilers that we do sell here in the U.S. as well as all over the world, and they harvest their own poplar tree forest farming that they do. So poplar trees go from a stick to about 3 inches in diameter in a few years, and they harvest those. And the nice thing with poplar is they regrow, so they continue to reharvest. They have thousands of acres of these trees, and that's one way they heat their this building with. The other way, they take all the cow manure from all the farmers, because this is a total farming community all the way around this whole facility. They collect all the different types of manures, and they do a wet fermentation, and then they add enzymes to it to where it starts to produce methane gases, which they collect in a big bag in this big building with a tent on it, and then they send it out to another building to be cleaned and dried, and then they can actually put that right back into the system. So it's a lot of amazing things, as well as that you can see that they have all these voltaic cells on their roofs. Over here, there's a whole bunch more, as well as this is actually an airport here. As you can see, we train quite a few people over the course of the year, and that's throughout all our different facilities through over the world. What you're looking at here is this is where you would come to train normally. Today you're training out of Massachusetts. This one here happens to be out of Rhode Island, Warwick, Rhode Island. Here on the very top of the building here is our live fire training facility, where we have 8 of these boilers connected, as well as 200 boilers, which is the next model up, as well as 300, as well as we offer commercial classes as well. So we try to tend to go a lot more hands-on in the classroom now. So as a contractor for over 40 years, that's the best way to, in my opinion, to teach and learn. So with that being said, let's go. So here is a nice little website that you might want to write down, important website for anything with Viessmann. I actually Google Viessmann Pro Login, all one word, and then you'll get this to come up as well. But I go into the Pro Resources area. And when I click on that, I can save all this to my home page or as a favorite to my phone, which kind of looks like an app on your phone, but it's not really. What you can see here, now you can get all your current manuals, your parts catalog, and then they have this neat little thing called the fault code checker, which I'll get into a little more down in the presentation. As well as installing most of their products for over 30-something years in the US here, I can get all the historical manuals as well. You can go on the site, you'll see a thing called the fault code checker, and all that's going to do is have you tell you how to download and load just the fault code checker. But like I said, I download everything and save everything as a favorite. You'll find a lot of good information like in Vito spec here. It's engineering specifications for commercial as well as residential, what pumps you may need for the jobs, what parts you may need for the job, such things to that nature. The other really nice thing is you can see the product reference guide, so all our different products, little helpful hints in there, sizing and all of that. Another cool website that we have is for the US Academy, and as if you've been there, there's a lot of cool videos on there, a lot of neat little helpful information, as well as signing up for future classes that hopefully we'll have pretty soon in the near future here. Looking at our Viessmann boiler lineup, really the only couple things that are not here are our solar panels as well as our biomass wood chip boiler, which we do have those in high schools in this area as well as colleges and as well. They burn on wood chips. So now you can see all our different gas-fired boilers from residential up on the top here, being our 200 boilers that you can cascade into a rack system and have multiple boilers. And the 200s come in 9 different sizes up to about 550,000 BTUs, 530 somewhere in that. And then you could combine those all together and get quite a few BTUs off of that rack system, as well as it can be a single operation. We also do offer oil boilers, commercial as well as residential. We offer some nice residential boilers. I like them a lot. I've installed quite a few, even going back to our older boiler, the Vitodens, which I've had in my house now for about 22 years. This boiler here does come with 3 different burners, either the Riello, the Carlin, or a Beckett, 3 different controls, a couple of our controls, as well as the hydro level control itself. A couple of commercial boilers here, the CM2 as well as the CA3. Those are larger boilers. This boiler goes from about 1.5 million to 6 million, and different ranges to that. Here's our residential condensing boilers here. Today we're mainly going to be talking only about the 100, but I like to talk about our full line because there's some differences between them, and then there's some comparisons as well, as we're talking about the Vitodens 100 today. This boiler here, as you can see, it has the inox radial heat exchanger, which we do produce our own heat exchangers. We make them ourselves in that factory that I was showing you earlier. But as you can see, the 200 model and the 222 model have the same exact heat exchanger. The only difference in being that the 200 and the much larger sizes, that coil is going to get much bigger. You'll see that our passageways are much larger than most, so less chances of blockage, where you saw with others, and as I've seen with others as well. So the difference between the 1 and 200 is mostly all your technology in the boiler. The 200 has a Lambda Pro, so it's sort of like having an analyzer in the box. It does self-calibration, as well as the 222 is pretty much the same as the 200. The only really difference between these two is this has a 26-gallon storage tank in the bottom of it, which actually produces as much as about a 60-gallon indirect tank. So if you're short on sizing and room, it's a nice little boiler. I put a bunch of them in there. They work really well. As well as the Vitodens 300 here is a different type of condensing boiler. It's a high mass condensing boiler, whereas we're going to be talking mostly today about low mass boilers, which the 100 has about a gallon of water in it. The Vitodens has about anywhere from 13 to 15 gallons, but it's still a condensing boiler. Different type of heat exchanger as well. It's a different type of boiler. To me, that's their Cadillac of the boiler there. We're talking about the 100 today. just to take a quick look at the cast iron boiler, because in this area and other areas around here, oil's pretty predominant still. I like to show this boiler because it's a neat little boiler. It's a true triple pass boiler with a stainless steel chamber, and so it comes to a steady state quicker. Less chances of sooting or anything like that with that stainless steel. Comes to a steady state much faster. One swing open door, and like I said, it comes with 3 different burners. We also offer indirects, if you didn't know that as well. We offer 16 different models from various sizes, from 41 gallon to 200 gallons, as well as horizontal, where you can put that oil boiler on top of a 41 gallon, or they go up to 120 as well. The horizontal can be stacked, so if you need space, you can stack the horizontals on top of each other, up to 3. With that being said, they also can be loaded with steam, so if you want to heat, if your steam is in your world, these horizontal tanks can handle steam pressures. So just to give you a quick little idea of Viessmann manufacturing. Now we're going to get into the Vitodens 100 B1HA and the B1KA, and I'll explain what that means to you in a minute here. And this is a product overview, so if you're interested in service and maintenance, I recommend that you do come to our service and maintenance webinar, as well as our hands-on training. So today's objectives of learning, we're going to go over the difference between the HA model and the KA model. We're going to find out where the applications where you can put these boilers and what they're suitable for. We'll list some 4 features of the Vitodens and their benefits, and the preferred method of piping these boilers. And this preferred method of piping pretty much goes along with pretty much everybody else's boiler, so you might learn something that might help you here. With that being said, let's get going. And with a show of hands, how many people are sleeping yet? All right, I can't see anybody. All right, so here we go. We're going to be talking about the Vitodens 100 with the inox radial heat exchanger. Go over the nomenclature a little bit here. As we can see, the B stands for condensing. The 1 stands for that it's the 100, so it's the newest one in the line. The K stands for it's a combi unit. So that's the way I always look at it, K for combi. And then H is for a heat only. So heat only, you can do heat, or you can go directly over to the indirect tank right out of the bottom of this boiler using the pump in the box. I'll explain that more as we go on. So the HA model right now comes in the 2 sizes, the 94,000 BTU and the 125,000 BTU. These boilers do go down to a 5-to-1 turn down ratio. We find that the 5-to-1 turn down ratio is the best way to get the cleanest combustion at the lower end of the scale. The KA model comes in the 125,000 BTUs, but when you're sizing this boiler for your gas piping, your DHW has a boost feature of 149,000. So make sure you take that in consideration if you're on the cuff of being just enough gas piping on your house. This boiler can be strictly a standalone boiler, I should say. It is a fully modulating condensing boiler. We do ship out the conversion kit for the LPG with the manual. This can be fixed set point, or you can do outdoor reset. You can do it either way. And this is going to be either on demand with the turn of a faucet, or you're going to have an aquastat or our number 5 domestic sensor that will call on an indirect tank. The quick 4 pipe design is pretty cool when you see it. We'll show that in a little bit here. It's going to be a wall mount or a floor stand. If you're going to do floor standing, that means you're going to use one of our racks. You're going to find that it's really simple to pipe and it's easy to wire. Not a lot to do on this boiler here. It's pretty simple. programming, you're going to find that there's only about 15 total codes in the whole boiler. That's what makes it pretty quick and simple, and you're probably only going to maybe use 3 to 4 of those coatings. And then maintenance, if you come to our service and maintenance, you'll see how quick and easy it is to service, and you can service it, so it's not a throwaway boiler like there's some out there that you can't even get in there and clean the heat exchangers inside the fireside. So your common applications, so they're ideal for small homes, condos, apartments, small apartments, townhouses. You can do a traditional DHW storage, and as you can see in this picture, with seeing that it is the HA model here. You can see now how it's piped right over directly to an indirect tank. So when you get this boiler, it has 2 caps on the bottom here. So you can put this boiler in, and if they have a gas-fired hot water heater down the road, you can hook it up to an indirect. Just an option there. Same thing with the KA model. This one here, you've got to be a little more careful where you're putting it. You should be diligent and do your water flows and check your gallons per minute and your faucets, your labs. We don't want a rain handler that can do 7 gallons a minute on something that can only produce 3.5 gallons per minute. You also can see how we're doing system separation here and how we can add zone valves or whatnot to the other side here. We'll get into piping in a few minutes. The components on the boiler itself. On the very top of the boiler, you have the venting options. We can do coax right off the top of the boiler. You would take this vent adapter part off here, this little rubber O-ring, and then that will give you access to the fresh air side, and then your exhaust is going to go into the center there. If you're doing 2-pipe, you're going to put your exhaust here, and then your fresh air is going to go into this. We'll get into that in a little bit. This is a premixed gas modulating burner, meaning that this gas valve is a negative gas valve, and that fan's getting communication to it, telling it how much to ramp up and down and how much gas to pull into the fan and into your venturi. It does have the hydraulic bypass switch inside here, as well as the it's a 3-speed pump. Normally you're going to just leave that on the normal speed that it's on. The diverting valve is what's diverting it from the flat plate or to the indirect storage tank. We'll get into that a little bit more as well. We got the new LCD touchscreen. So if you had the prior model or did prior models like I did as well, you had those 2 nice little dials on it and that you had to try to program on there. This is much easier. And if you ever did come to those dials and you didn't know how to do it, you go to our Academy website, and there's one of the tech support guys, Mo, actually shows you how to do it and makes it nice and simple for you. Hydraulic connections on the bottom. We got knockouts already there for you for your electrical here. This boiler does have a condensate and a condensate trap built into it, so there's no need to put another trap on this system. You'll find that I'll talk about condensate because that was probably one of the #1 calls that we got improper installations of condensate, either adding another trap or tight fittings. The KA model does have this flat plate, expansion tank, flat pancake expansion tank. It's about the size of an Extra 15. It's about the half of its size, but that's because we have a flat plate and we're diverting over to a flat plate heat exchanger. That could be the only expansion tank you need for your installation. If you can keep the installation under about 25 gallons of water, say in a small apartment, you could use that expansion tank, as well as you wouldn't have to pipe primary, secondary with this boiler if you had under 25 gallons of water. I still recommend doing system separation to get the most accurate out of this boiler, but you can't do that with this boiler. So nice small apartments, I've done it before on small apartments. If you're putting the boiler in the room, you're going to have the hot water right there as well. The inox radial heat exchanger with the matrix cylinder burner is on this burner. And then at the very top of the boiler, which is a cool design, is where your safety relief valve goes on the very top here. HA model, not much difference. The only difference that it does not have that expansion tank or the flat plate heat exchanger, because remember the tappings out of the bottom of this. Now we're going to go over to an indirect tank, and you're going to use the pump inside the boiler just to pump over. So it saves you a lot of time on your installation, a relay, a pump for your indirect. So you're using the same pump for your primary, secondary, as well as your domestic piping. Here's your boiler operating ranges here. As you can see, maximum temperature is about 176. It does go up to about 180 with a little bit of override. Fixed high limit is fixed to go off at 210. Your flue gas temperature sensor is about 214. We have altitude ratings, but there's also altitude adjustments inside F coating. Unless you're in the Midwest or in Colorado, in those areas, which you might possibly have to adjust that if you're over in that 5,000 to 10,000 feet. As you can see, there's not a lot of water in this boiler. That's why we are piping it primary, secondary. 1.02 of water inside this boiler, so not a heck of a lot of water. Our maximum flow rate through the boiler is 6.2 a day. We already got the boiler in there to figure that out. I'm sorry, we already got the pump inside the boiler to figure that out for you. So there's really, it's going to maintain that proper GPM as long as you're doing your closely spaced tees or your low loss header if needed. They're not too heavy. As you can see, they get fairly light for a boiler. And then your maximum for your domestics about 145, and then there's your continuous flow rate. That's what your activation has to be for your flow sensor, and to not to exceed the 3.5. Just showing you just another way of looking at that. Main features in the boiler, in my opinion, is this heat exchanger. It's high quality titanium infused stainless steel. So you're going to find that the passageways are much bigger. Comparing it to maybe a Giannone, our passageways are a lot bigger. They have the gap design in there, and they're very rigid. We do make this. I actually saw this being made. It was pretty neat to watch. It folds, it bends, it welds it all in one quick process, comes out the other side, and it makes the coil here. We do have a particular gap, annular gap in between the heat exchanger. As you can see, it's a 0.8. The main reason why we want to keep it at that distance is that's what we found that would give the most heat transfer. So when that burner comes on, and then that fan comes on and starts blowing, it goes through those annular gaps there and then gets blown through to the back side of the boiler. There is a baffle inside this boiler, as you can see. It's the center position here, and on the back side here is where all your most of your condensing happens, and so that side's really usually always pretty clean. As we have our return water coming back, our hot water burner side here, we're about 1800 degrees in here with a flame. And then when we're blowing over, by the time it gets over to this side, we're about 27 degrees higher than your return water coming back to the boiler. So this is, to me, why you need this titanium infused stainless steel and why it's important comparing it to others. And to me, it's longevity. We got some very acidic condensate going on in there, as well as 1800 degrees on one side. So you need something that's going to hold up to all this corrosion and the heat. It's a good heat transfer as well. And you'll find if you do come to our service and maintenance class, it's really simple to clean as well. Here's our galvanic chart here, just to show you where our stainless steel is on the far right there, the 441 stainless steel. And that's a stainless steel that's got the titanium infused in there. So you can see we're up there as a high quality material. Normal 316 stainless steel here, somewhere here in the middle here. And then aluminum's down the end here. Great straight heat transfer there, but we're at the lower end of the scale as far as handling temperatures and acidicness. Venting options. So polypropylene, we offer as one of ours, polypropylene rigid, CPVC, stainless steel, or flexible liner. Coax venting as well. If you haven't done coax, we offer a coax venting here at Viessmann called Cox Geeling. Door vent also works, as well as Centrotherm. I've used them all. Just be aware of who's you're using and follow their guidelines, because with our Cox Geeling, when you're doing a pipe and a pipe out with this one here, you're doing a flush cut, where Centrotherm and Duravent, they usually want about 1/4 of an inch sticking, 3/8 of an inch sticking out. So you want to make sure you know who's you're putting in, so there's no chance of cross-contamination of doing it the wrong way. Prove the materials. There is no common venting with this boiler. A maximum equivalent length. So if you do see equivalent lengths, that's usually your fresh air and exhaust combined. Nice thing with this boiler, your first 2 fittings coming off your fresh air and exhaust are not counted in your finish calculation. Materials must meet the UL standards, and no combustion, no exhaust with PVC. And it's not just about the temperatures with PVC. They've done studies on PVC, and the heat and the chlorides start to get leached out through with the condensate. Will start to leach the chlorides out of the PVC and work its way back into the boiler and start to do harmful things to the boiler. So it's not just about the PVC ratings of the temperature. It's about the breaking down of the PVC. So fresh air only. And be aware when you're doing PVC that your 90s are, your short sweep 90s are about 8 feet, and your long sweep 90s are about 5 feet. That's why I like polypropylene and not a true 90. They're an 87-degree 90. And the calculations in our book say that polypropylene 90 is going to be 1.5 feet in your calculation. So that can save you some distance if you're doing polypropylene, and if you need a little more, maybe even do it on your fresh air, so you can get a little more distance, because that 8 feet 90 can take up some distance. Make sure that you do blow out all your shavings as well, because they do eventually work their way into the burner tube and they'll cause problems. So make sure once you do cut your PVC or your polypropylene or your CPVC that you're blowing out your PVC shavings. If you're going to do 2-pipe system, you're going to pull the center of that ring out there. It's a rubber grommet ring there. You're going to put your 2-inch right in there after you pull that out, and your fresh air is going to get connected right to here. You're going to just stick your 2-inch right in here. The gasket's there, and it's going to go right to polypropylene. It's designed for that size. If you need to go farther distances, you can put increases in here and go farther distances. So we can do it all different ways. This doesn't have to be a balanced system, so the farther away you can get those two apart, less chances of cross-contamination. They show all different ways in the manual, but like I'm saying, you could have your exhaust going out here 6 feet, and if it was 200 feet, you could go out 175 feet the other way. It doesn't have to be balanced. I would always go the shorter distance or whatever is more expensive to put in, and then separate them that way. Sometimes too, I used to take fresh air out of the chimneys I took out, the brick chimneys, to bring fresh air through there and go through the top. That way, if I'm near ocean waters, I'm not sucking that fresh air right in, salty fresh air right to the boiler, and let it drop in the room. Just be careful of 1-pipe system. So if you're doing 1-pipe system, you're going to take that rubber ring off the very top here, and then you're going to take your fresh air from here, as well as your knockouts on the side here. Just be aware of fresh air, make sure that your squares are the right size, and make sure that you're getting any more, the air that you're taking out is getting replaced with air coming into the building. We do offer the coax venting system. We offer a sidewall venting as well as roof venting, and both have different types of terminations. But just be aware on sidewall venting, there is a stop over here, and you're going to push that stop all the way up into the house and then cut your pipe as needed. Our cox scaling does come with this cage here. You can put it on or not put it on. It's for protection, but that's the main reason why you want to make sure you put that stop up against the house, because it's designed for a certain distance away, or you'll get fresh air being blown into your exhaust. Vice versa, I'm sorry. Just showing you your maximum combined distances and how far you can go. In the venting manual, it gives you all your different guidelines. Nice thing with this boiler here, you can reach in the side of the box by opening up a flap, grab the venting manual, take it to your job, size it out, and then you can highlight it. You don't really need to leave that one there on the job site. It's for venting. Once the venting's done, it's done. So wall mounting, floor standing. So as you can see, that wall mount, now that we've all become carpenters now with doing boilers, we have to build a wall, hang a boiler. But we do have a feature that you can get our floor stands. The nice thing with our floor stands, they do have adjustable feet. So those are adjustable and it can get bolted to the floor as well. The neat thing, say small things amuse small minds, but any of our floor standing, anything that 222 boiler, our oil boilers, our indirect storage tank, all have adjustable feet. So you're leveling it off. You're not smashing a piece of copper trying to stuff it underneath there to get it to level off. For pipe hydronic design, it's nice and easy to pipe. What you're going to find is that these fittings, you can reach inside the boiler, pop the clips off, and the fittings pop right off. The only one that doesn't really pop off, and you can if you needed to, but normally what I would do is I pop the two fittings on the side off, and then pipe in my gas. That way no wrenches are in my way, and then you can pop the fittings back in with a piece of pipe on them if you wanted, or even have it partially piped in there. Just to show you how the piping works and how the internals work on the inside of the diverting valve. Diverts on the HA model here. When you're making heat, the diverting valves allowing the water to get pumped through the heat exchanger, come out and go out to your heating system. So at this point, I always tell people when you're repiping our boilers or looking at our boiler, it's just like looking at a faucet at your sink. Your cold water inlet is on your right-hand side. Your hot water outlet's on the left-hand side. So piping it and setting it up is just like looking at a faucet. So when you're making hot water, you're not making heat, it's one or the other. On the KA model itself, now it's just a little slightly different. Instead of going over to an indirect storage tank, we're now going to a flat plate heat exchanger. Now you can see the expansion tank and where the expansion tank is located and why they have an expansion tank. Talk about primary and secondary piping for a moment here. With this boiler here, you can do it either way. Just making sure that if you are doing closely spaced Ds, you do them properly. There is a mathematical equation, and normally what they want is 4 times the pipe diameter, and then that's going to be center of the T here, the center of the T. So if this was a 1-inch pipe here, that would be 4 inches center of the T to center of the T. They normally want to see 1 inch going over and coming out or greater. Our low loss header that we do provide does come with 1.25 inches here. You can go down to 1 inch with that if you like on the 100 models. Talking about primary, secondary, I had somebody that came to my class, and this is he told me how he teaches guys how to solder as well as how to pro press. I thought that was a great idea of getting guys to learn, modern technology with pro press, which works really great, saves time. But when the battery dies or dead, does that mean you stop the job and go home? No, that means you go out to the truck and you grab the torch and you can solder. So it's a nice little way to get the younger people involved into soldering, because it is kind of getting to become a dying art, just like black piping and all of that. So it's a good crossover. That just happens to be a Webstone 4-way T that's already designed for closely spaced T. And then they just took the fittings out of the boiler, pop them in here, and then when they get to the job site, they just pop them in and then put the clips back in, and you're pretty much done. Talk about primary, secondary, and hydraulic separation for a second, and why we want to do that. Remember, there's only a gallon of water in this boiler here. So if we heat that water too quick or too slow, we're going to bounce off a high limit or really fast, because these boilers heat up very quickly. So you're going to bounce off a high limit pretty fast and quick. So the other thing is you want to make sure that your pump can handle it, or not be too much pump on your system side and not activate a flow switch, or be not enough pump and not, or too much pump and not take any heat out of the boiler. So basically the pump inside the boiler comes on, it starts to heat one side of the heat exchanger here, or your low loss header. When your system pump comes on, it comes on and then he's taking water out of the low loss or your closely spaced C's and goes to your emitters. This way, this pump only has to worry about your system side, and then this pump here only has to worry about the boiler side. And what that does for you as well, gets the flow it needs, less likely to short cycle, not going to be affected, and being that the pump's already in the boiler there, you're going to stay under that 6.2 GPM. Looking at it, what's inside the box besides the heat exchanger. So here's your diverting valve and your flat plate heat exchanger in itself. It is a Grumpus pump inside here, so it's a good design pump. There is a high vent in here, so when you're first initially filling and venting the boiler, I recommend that you open the venting on that, as well as open the bleeder screw and get some water inside that pump here. As you can see, there's little clips right here. You just pull those clips out and those fittings pull right out of the bottom. It'll make it easier for your piping. The flat plate heat exchanger, very quick and easy. There's only 2 screws to hold it in. I recommend pulling the burner. There's only 4 screws holding the burner. You get that out of the way. You can actually reach in there and get any pot in there very easily. It's not like other boilers that I've taken the pot out and I've had a hard time putting it in. You can pretty much get to all this stuff pretty simple. That's what I like about it. So now you can see all the clips come out. Their sizes, 3/4 inch MPT. When I started putting these boilers in over 30 years ago, these came in with straight threads and you had to put adapters on them. So it was a little more part of a lengthy process, as well as it came in German, and you had to take it out of Celsius and put it in Fahrenheit. And on the first original ones, there was no Fahrenheit. You looked at a sticker that had on the side of the boiler, and I had no Siri or phone to ask how to convert. So at this point here, and remember, get the questions. There's no such thing as a dumb question. The only dumb one is the one that you're not going to ask and wish you asked.
Looks like we don't have any so far, Jay. If you want to continue, and we'll hopefully have some questions at the end.
All right, great. Well, hopefully they're getting all the information. That's fine. And like I said, come to further classes, and you'll find the hands-on is a little more fun than watching a screen. So let's talk about the benefits of a low-loss header over closely spaced T's. Most low-loss headers are designed perfectly to handle the system separation and to do a few more other things as well. The one that we sell actually enables air vent. So on ours, we actually give you a bleeder with a bleeder key on the top. What I always used to do was get rid of the bleeder and get a 1/2 inch like Khalifi high vent or whoever's high vent 1/2 inch. Put it in top there. That's all the air elimination you're going to need for the system. So that would alleviate going out and get a spiral vent or an air scoop or whatever you want to use. It works beautiful. As you can see, the boiler water supply comes in and gets forced down because the nipple coming out of the side here is lower. So as it comes down, it forces the air to go up. As well as the bottom, as the return water comes in here, it really slows down to pretty much nothing. And it gives time for the stuff to settle down here. So normally on my installations, I would put a T here, come off to the side with my feed valve and expansion tank, and still have a boiler drain at the bottom here. So you can get all that crud up out of the bottom of that. We do sell the slow loss header here, and this is pretty much going to be the one that you're going to get for most of your residential houses here. We sell them up to sizes that are size of myself. This is the part number 4 here, and it does come with that insulation on the end there. So that is insulated, so it keeps the heat inside the heat exchanger itself. And the way we design low loss headers is not for the boiler itself, it's but what you have out in your system. So you need to know your GPM going out to your system to size for the correct low loss header. And like I said, this one here is pretty much going to be the one that you're going to use for most residential houses. Excuse me. So they do get pretty big. I found this one here and just to show you how big they can actually get. So people do system separation on big, large commercial jobs as well, so they can get pretty gigantic. We don't sell one that quite that big, but pretty close to the size of the gentleman next to it. We'll sell them about that big there. Talk about our fuel requirements. So if you learn our fuel requirements on this boiler here, you'll know that all our requirements from our residential 100 boiler here all the way up to our 6 million BTU CA3 boiler. All our gas readings that we require are all the same. On natural gas, we're looking about 4 to 14. On propane, we're looking at anywhere from 10 to 14. What I found is when I did propane as well, around 12 and a half always worked best for me. But at this point here, I always like to point this out because here's our nice little boiler put in here. And on our prior presentation, we used to have a standard atmospheric boiler in there. And what happens if your gas piping is too small on an atmospheric boiler? Well, the flames on your ribbon burners start to get smaller and they still run. So now we bring in one of our boilers or somebody else's power burner. And we throw that in there and now we start sucking on that gas and the boiler snuffs out. So it's important when you first go to size out these jobs to make sure that your gas piping is sized accordingly. First couple of things I looked at when I went to look at jobs is first major one to me was where am I venting? How am I going to get these flue gases out of the house? And is my gas piping sized correctly? And are there going to be any changes to your gas requirements? Things that you need to know. There is an office change on this gas boiler here. So you're going to remove the 2 screws off the fan right here. Your 2 screws are right here on the gas valve, and then they screw right into your fan right here. This little rubber O-ring is normally seated right here and seats over this side here. When you get the new one, you're going to switch it over to propane. You're going to take this orifice, stick it inside this rubber O-ring inside here. There's a recessed area where this raised ridge fits into. Once you do that, you're going to insert it inside your gas valve and then put the screws back in, making sure that that rubber seat goes over that nipple as well. Once you do that, put your conversion stickers on your boiler where the yellow stickers are. When you first open up this boiler and pull down the cover of the control, you'll see a little yellow sticker right there in your face that says set up for natural gas. You're going to take that little yellow sticker that says now set up for propane, as well as putting your conversion sticker on the side of the boiler. There is a programming change, but you're going to find that this is a really simple, easy boiler to program. You'll find that there's only, like I said, 15 total programs in this whole boiler. And this might be one of them if you do propane that you would change. Nice thing with Viessmann is all your parts are changeable, not interchangeable, but they are repairable. The two KA and HA, all your parts are really pretty much the same exact parts, even your controls. When you get this control, we'll talk about that in a second, but if you have had to replace this control, you only need to carry one control on your boiler for either boiler. You just have to go into programming and tell the boiler which control you're putting into what boiler. When you first initially get to this boiler, you go to that coding address. You can't change it until you replace the control out. So that default setting is going to stay there until you change out the control. Talk about your electrical connections just a little bit here. There's not a heck of a lot to wire in this boiler. So as you can see on the left-hand side, there's a little plug here. That's normally located right here on the left-hand side as you pull down your cover. And talking about covers, there are two screws that hold our cover on. They come from the bottom. So if you look up here, you'll see a screw on each side. You're going to take those two screws out, let them drop. They will not fall out. Then you're just going to lift up the cover off the little lip on the very top here. Once you do that, there's two little ears on the control, left and right. You squeeze them and the control will fold down. You'll see this little plug right here. It has one little screw right in the center here. I usually take that one little screw out so I can pull the wires up so my old eyes can see the numbers. Once you do that, your outdoor sensor is going to go on number 3 and 4. If you look down to the left-hand side here, you can see that the minimum wire gauge is 16 gauge. I don't know with a show of hands here how many people can find 16 gauge wire anymore. So usually it's going to be that 18 gauge wire that we use for thermostats. If you can find 16 gauge wire, it's fairly expensive as well. But just be aware your maximum distance is about 115 feet with your outdoor sensor. Pretty much here in the future coming up, I believe they're going to be wireless like they do already have in Germany. And that will save us a lot of time as well. The other thing they always recommend is do not put it near high voltage because you could get some interference on your readings with your outdoor sensor. The other thing it tells you is always you're going to put it on the coldest side of the building, which is usually going to be your northwest side of your building. We're not going to put it right above or below the exhaust that we just drilled out or a dry air exhaust because guess what? You'll be calling tech support. The other thing we're going to be doing here is we're going to be just plugging into the wall. With most of these wall-hung boilers today, we need some type of plug. In Rhode Island, they require a GFI plug. So if you want to put a GFI, to me, battery backup as well is with all these things become so sensitive in nature because they're all circuit boards. You'll save yourself a bunch of money with a surge protector with battery backup. Don't really need battery backup so much with this boiler here, but when you get to a 200s and 300s, it's well worth the $100. So that's what it looks like with the plug. So now you can see there are numbers on there. And as I was saying earlier, there's usually one little screw holding that plug in right here. Next is either our T-stat wire or our end switch coming from our zone control, or it can be pumps, it can be zone valves, and we're going to send, it could be multiple. It doesn't have to be a single operation. You could have 6 pumps here. Remember, this boiler is 125,000 BTU boiler, so we can get some heat out of this boiler. So this is just showing an end switch off a single zone, but it could be a multi-zone, and that would be your XX or your TT coming off of other boilers. Or if you're doing a small apartment and you just want to run it off a thermostat, we would just send our TT from our thermostat right over to the control and then use the pump in the boiler. Remember, it has to be under that 25 gallons of water to do so. It also must be a dry contact, so that means there should be no voltage on this device. It has to be a dry contact. So with this boiler, is one of our only boilers that we do carry that you do not have to put your outdoor reset control on there. But most of these rebates that we're getting in my area, as well as in other areas that I talk to, the requirement is to make these boilers efficient, and this is the way you're going to make those boilers efficient, is by putting that outdoor sensor on and modulating to the outdoor temperature. But like I said, if you do not use it, you do not have to put it in. Showing you on the boiler itself, this is out of our manual itself here. We just added color to it, and it's also in our startup manual. So that website has a lot of neat little things on it. So when you get a chance, take a look at it. If you're bored, take a look at it, because it has a lot of neat little things all over it. But that being said here, if you take the cover off our boiler, you're going to find our spare fuse here. And then there's a spot, if you did it the old-fashioned way and you wanted to power your transformer for your zone valves, you'd come out of here and power one side of your transformer. But this still has to be a dry contact coming over here. Where most people nowadays, what they're doing is they're using zone controls. That makes life a lot easier and neater. With this application here, it's showing zone valves on for this application. So now all your T-stats are going to go to the box, as well as control all your zone valves. Your pump is going to be operated out of here, and then you're just going to send your XX over to the boiler, which is going to come over to here, your dry contacts on 1 and 2. Pumps, doesn't matter, zone valves, pumps, same thing. You're going to send your XX over to your 1 and 2 over to the boiler here. In this situation, they have our number 5 sensor here. Number 5 sensor is, like I said, our domestic sensor. We send that out with the boiler as well. Just showing you different functionalities here. This just happens to be a Takeo zone control. I can tell by the color of it. Thermostats are all coming to this control. We're operating this main pump. All these zone valves would come back up to here as well. And then we're just sending our XX over to fire the boiler. So as you can see now, we're piped over to our low loss header. For if you're using an indirect on the HA model here, all we're doing is piping over to the indirect. Piping is done. So you can see how quick and easy this boiler is to pipe, because we're using the pump inside the boiler, and we're using either our number 5 sensor domestic sensor or an aquastat. This is just showing a different setup with circulators using somebody else's zone control. And they're just sending their XX over to the boiler. This happens to be the KA model. So now you can see you're just piping your fixtures, your hot and cold going out to your units. This here is a cutout of our engineering drawn up. And so as you can see, they want you to put that there. But like I was saying earlier, if you take a half-inch high vent and put it up here, you can pretty much eliminate that. As well as you could take this here and do the same thing over here, but just make sure you're not putting this stuff right underneath there, because remember all that sludge and build up here. So pipe it off to the side and still have a boiler drain directly underneath there. And then that way you can drain all that muck and crud out of the bottom of that low loss header sensor. I'm sorry, your low loss header. So this boiler here is designed, we do send out the number 5 sensor. I do recommend using our number 5 sensor, even if you're putting it in somebody else's indirect. If you find that our sensors are a little thinner than most, so I always used to use the copper Never-Seez heat paste and put that inside the aquastat well and get a good heat transfer that way. But what you're going to find is that the aquastat sensor responds about 5 degrees faster than an aquastat. But if you have an aquastat already set up there and you want to hook up the aquastat, we also sell an aquastat production kit. for our indirect tanks. If you're using the aquastat on our indirect, you're going to find a tapping up here where that it's going to go all the way down into the indirect. If you're using an aquastat, you're going to use our recirculation tapping on our indirect tank, and then put our, it's like a bell coupling with a long aquastat well. It's a long well. If you're using the aquastat, what you're going to do is in turn, as you can see, the number 5 sensor, the domestic sensor that we do send you, has a white plug on there. It's going to say number 5 right on it. These little white 5 red spade connectors are usually tucked in the back of the boiler here. If you're going to do an aquastat, you're going to cut those off and just wire nut your thermostat wire to there. If you're using the number 5 sensor, you're just going to plug those spade connectors into that here, and then you're completed. If you're doing an aquastat, you're going to go in there into the control and tell it you're now using an aquastat control. Neat thing with this boiler now is the touchscreen control. So they made it a lot easier than the 2 knob turn prior model, which I put a lot of those in, and they were pretty frustrating in the beginning until I learned how to do them. And if you ever do, like I said, go to that website for the Academy and watch Mo's video. Makes it really easy. But to go over a few of the things and the functionalities of the front of the control here. When you're looking at the control itself, as you can see here, this actually represents a house and what's going on inside the house. As you can see right now, we're firing with 2 bars. Flame is on, and we can see another temperature over here. That's what's going on outside the house, so that's your temperature for the outdoor temperature. Remember, if you don't use your outdoor temperature, there's no frost protection. We have frost protection on this boiler, cold weather protection as well. So that means as soon as this boiler senses that it's 42 degrees outside, it puts this boiler in protection mode and maintains 68 degrees on it at all times. So less chance for the boiler to freeze up. The other thing is warm weather shutdown, 2 degrees above your room temperature set point is your warm weather shutdown. So you'll lose that as well if you don't use your outdoor temperature. Going over the symbols and their status types. On the left-hand side, you can see in the heating mode, the radiator is going to come on. So if the boiler is firing, you look over here, you'll see a radiator symbol here. For firing in the DHW, which is your domestic mode, you'll just see a faucet in the symbol here. The burner symbol means if you see that illuminated, that means that the boiler is running. And depending on here, what output that you're in. So in this boiler here, you can see that there's 5 bars here, and you can be in the 20%, 40, 60, 80, and 100%. When you're setting up this boiler, you're going to come to the serve part of the portion and programming, hit that, and then you can actually do 20% to do your low firing test, and then go through serve mode and go into the high fire test and put it into high fire and do your high fire CO2 testing. Additional symbols on the screen. If you see that triangle with a lightning bolt in the center, that means you've got a fault. Soft faults are going to be there. If you lose your outdoor sensor, it's going to tell you that it's not going to be a hard lockout. If you have a hard lockout, you're going to have to go down and hit and hold that R button for the reset button itself. C or F, that means you're either in Celsius or Fahrenheit. These other symbols here, we got mode. You're going to press that mode button to get into whatever mode you want to get into. So if you want to get into fixed set point, you're going to hit the mode and this is going to flash. If you want to get into your domestic, you hit mode. Once something is flashing, you hit OK, and then that's going to allow to change set points on your fixed set points. As well as if you went into mode, hit your arrow until serve is flashing, hit OK, and that's where you can do your high, low, medium fire and do that numeric 20, 40, 60, 80%. The other special functions, so that's your flue gas settings there. So you're going to hit your mode button. hit the arrow until serve is flashing. So this will be blinking at you. Once that hits there and it's blinking, hit OK. Then hit your up arrow. You'll go from 20, 40, 60, 80 to 100%. The eco or comfort function is only for the KA model. And the way I always explain that this boiler gets shipped over, you know, all different countries like England and places like that where they may have this boiler right in their kitchen, and most of them do in England. The comfort mode, normally what that does is it keeps the flat plate at a certain temperature all the time. Sort of like maintaining a tankless coil in an old cast iron boiler. So it's kind of doing that same function. So as soon as if you're in the kitchen and your boiler's 2 feet away, you turn on your faucet. It's almost like on-demand hot water. I found with all the ones I did, I always put it in the eco because these things heat up so fast, you're not going to notice a slight delay. It's still going to push all that cool water out of the pipe. That's the misnomer that a lot of homeowners think that they're going to get that on-demand hot water, meaning that, hey, when they open up their faucet, why isn't the hot water right there? So that's a little explanation on the installer's part there, and so that they know that it's still going to operate pretty much like their other system, that it's just going to take a few seconds. The other thing I did find with keeping your flat plate heat warm, if you have a distance away from there, you might get a quick burst of cold water. By the time the boiler fires and gets up to temperature, you might get a little burst of cooler water. Confi stands for configuration. So to get into all these different modes, you're going to hit your mode button, your arrow until one of them is flashing. Hit OK each time you're on there. On this one here, we're going to go to configuration, which is your programming of this boiler. So you hit mode button, hit your arrow until Confi is flashing at you. Once you see it flashing there, you're going to hit OK. There is a password requirement here. My password remembrance is Joe Namath. Joe Namath was the quarterback of my choice, even though I have Tom Brady in this area who just now got traded to Tampa. I grew up with Patriots who were pretty bad growing up, so I had to find a better team to watch. And then my age, it was Joe Namath. So number 12 is your password. Could be anything you want it to be. Channel 12 News. That doesn't matter. It's just the thing that helps me trigger the password. Look at that temperature displays. So here, as you can see, there's no outdoor temperature, so we have a fixed set point here. So it's going to show you the boiler actual temperature right inside the house there. When you have your outdoor temperature sensor hooked to the boiler, it's going to show you your outdoor temperature there on the outside of the house, and what's going on inside the house, the actual values of the boiler temperature. Domestic, it's only going to display your domestic set point, not your actual. Your boiler temperature set point, it does come defaulted at 158. So if you want to make it to go to 176, you're going to make that adjustment. So you're going to go hit mode button, then your arrows until that radiator is flashing. Once this radiator is flashing at you, you hit OK. And then that'll allow you to change that temperature there. And you're going to hit your up arrow to the 176. So now you can see all the different screens of what's going on there. Oh, sorry, wrong way. Sorry about that. Same thing with your domestic. If you want to make changes to your domestic temperatures, you're going to hit the mode button first. Once you hit that mode button, you're going to hit your arrows until that faucet is flashing at you. Hit OK. Once you hit OK, then you can make that change to your domestic. So it's pretty quick and easy to make adjustments on here. To get into programming, we're going to hit the mode button until Confi is flashing or configuration. Once that is flashing, we're going to make sure we hit OK. Once we hit OK, the screen is going to come up here. We'll hit OK one more time because this is going to be highlighted. Once we hit OK, we want this side here to highlight. And then we're going to go with our up arrow and put that number 12 password in there. Once we hit that OK on it, the very first code is going to come up. And normally when you come to our coding class, we'll go over what each individual code and how it works. And we actually have you do that in the boiler room itself. But the first neat one that comes up on this boiler here is number 1, and that's your fill mode. So when you first install this boiler, it's what we call purged mode here in the US. Nice thing about this boiler is if you put it in this purge mode and you have a ball valve underneath your boiler there, you put that ball valve on, excuse me. You close that, and then the boiler drain that we give you on the left-hand side is now your purge station. You have this come on, and what it does is it exercises your pump to help you fill the boiler as well as to get the air on. It comes on for about 30 seconds to a minute and shuts off. And same thing, it repeats the cycle, so it helps get that air up to the top. And at the very top of the boiler, we give you a key as well as a vinyl hose to help you bleed that air out of the system. Taking a look at what's inside the box and what it comes with. So when you get our boilers, the neat little thing with our boilers is you don't have to open up the box or cut open the box to get any of the manuals or any of the fittings that the boiler comes with. There's little flap doors on the side of the boiler. You open up the flap doors. There's all your fittings here, and then your manuals in this flap door here. So you get this boiler a couple of days early and you want to read about it, what it does and how to set it up. Or you can get your venting manual so you can go do your venting sizing. You can do that without even opening up the box. Take a look what's inside the box here. So on the HA model, as you can see, we have a number 5 sensor in there. That actually has a number 5 right on it. And that's going to be your domestic sensor going into your indirect tank. As well as there's your bleeder key here to bleed that little Allen 4-way slot on the top of the boiler to get the little micro bubbles out of the top. Here's your outdoor temperature sensor. And remember, northwest side of the building with that. We actually give you a temperature sensor, mechanical temperature sensor, as well as pressure sensor. As well as these go underneath your boiler here. So these are your fill and drains. Your relief valve comes with it. That's your Omega clip that you stick on top of the boiler. You slide the clip in and it locks that relief valve in. So nice service place to get it. The very top of the boiler, your minimum water drainage, get that out of there. You can take that relief valve out very quickly and without losing any water out of the boiler. Really. Comes with the gas valve as well and the hanging brackets. On the KA model, as you can see now, we lose that number 5 sensor. But what we do gain with this boiler here is a domestic TMP valve, temperature pressure, and that's for the domestic side. It also comes with that T there as well. The T is 3/4 inch, so coming out of the bottom of this boiler is actually 1/2 inch. So somewhere you're gonna have to put some type of increaser to come over to the 3/4 inch T. Other things that we like to talk about is condensate coming out of the boiler. And this is not just condensate coming out of our boiler, it's out of everybody's boiler. Excuse me, when I first started putting these boilers in, nobody ever really talked about condensate until I started noticing my impellers on my pumps getting eaten away in a couple of years. So it does get a pretty acidic, and that's not just with ours, it's with everybody's. So we should be adding some type of neutralization to the system, whether it be ours or others. Just make sure that we're as much condensate as we're producing, that neutralizer or pump neutralizer can handle it. And for each gallon of condensate, sorry, it's getting later in the day here. For each gallon of that condensate that we're grabbing out of this boiler, we're trying to grab about 8,000 BTUs out of that condensate. And so we're trying to get all the temperature before it leaves the boiler. So normally coming out of our boilers, you're going to see it's about 3.5. So we can check our pH is coming out. I've seen them in others as well as ours in the 2 range. So let's add some type of neutralization in there. This just happens to be one that we sell. The neat thing with this one here is that bag is changeable. So you just grab the bag of pellets if they need to be changed, or if we're not condensate in these boilers, you're gonna find that these things are gonna get as hot as a brick. That's why it's important to get water inside these and make sure that we're condensate and check them once a year. Because if we're dumping condensate into a septic system, it's going to kill all your bacteria. So that's why we want to need some type of neutralization on ours or everybody else's units. So with that being said, here's the one boiler here. This happens to be the combi unit here, because you can see this 1/2-inch pipe coming over to the bottom of the boiler and tying right in here. Nice little setup. They did closely spaced tees on this boiler here. B1KA. Nice thing too, they leave the manuals on the job. It's got his card up here. I always welcome if anybody wants to send pictures. I'll be more than happy to put your pictures in. So now you can see that relief valve and how they mounted it so that it takes the pressure off of that clip on the top. Nice install here. So now you can see the HA model here now. So now we're going directly over to an indirect tank, and all he had to do is add a purge station here. Quick, simple piping. He did do the low loss header here. Nice thing he also did there was he put anti-scald valve on there. You can actually increase your tank size by just putting that on there and then increasing the water temperatures going over your indirect. Nobody's going to get burnt, as well as you can actually double production out of that indirect, almost pretty much double it. Another nice looking job. That is our EVIA 42-gallon tank. Nice thing about our tanks is the cover comes right off, and then there is a 3-inch screw cap on that, screwing right onto a stainless steel tank. Lifetime warranty on these tanks. The nice thing with the tanks is they're the 444 stainless. Like I said, they handle the high chlorides. Here's an apartment complex. They weren't quite done, but nice looking system, nice looking job. Just didn't finish the venting, but he took the picture and sent it in. So let's just go over some of our learning objectives, what we went over today. Excuse me. All right. So we did describe the difference between the HA model and the KA model. Remember, the HA, it could be for heat only, or you can tie in that indirect, take your 2 caps off the bottom and pipe right over to the indirect. A lot of time savings with these boilers here. Application-wise, on the HA and the KA, the different places that you can install these. Remember, small houses, apartments, condos, things to that nature. Pretty small houses, not too big, but remember 125,000 BTUs is 125,000 BTUs. Just pipe it accordingly, and then use an indirect storage tank on your bigger houses, and you'll be less chance to run into problems. Remember, with the combi unit, you got that 3.5 GPM, so you're only going to produce so much water. The 4 features and benefits, I gave you quite a few benefits and features off the boiler. The heat exchanger to me is one of the #1 benefits with this boiler. It's long lasting, longevity, good quality material, as well as your fittings can come off. Piping and wiring is very simple and easy, as well as you'll find if you come to our service classes, servicing this boiler is really simple as well. Preferred piping methods, closely spaced tees, low loss header, things to that nature. Or remember, if you're under that 25 gallons of water, you can use the pump in the box and just pump around the house with that. And I'm talking usually most likely a smaller pump. So last call for questions. Hopefully you get the call, questions and the answers that you come looking for. And I hope to see you in the future classes as well.
We did get one, Jay. Is there a way to hook up a common for a digital thermostat?
Not on this boiler here, no. But you're going to find that the Nest thermostat can tie into this boiler because the Nest no longer needs a common wire. I recently installed one for my brother-in-law, and I had the same type of unit, so I called them, and there's no need for a common wire anymore. So a neat little fact there. So no comment on this one. The future boiler might have RW and C. We've been talking about that with our engineers down in our engineer department in Warwick, and that's something that they're talking about. So that would be a neat little function as well.
We have one more question. What are close T's for, and why would we put one in?
Okay. Let me go back to that area. We also, when you come back to our classes, we give proper piping practices as well, and why you would use a closely spaced T and low loss header. So closely spaced T's are pretty much like doing a low loss header. Wait for that to come up. So here's your low loss header here on the right hand side. So remember in that slide I was showing you the system separation. So your pump only comes on your boiler side and circulates water on one side. Then your system pump comes on and does your water system separation on this side. That's what you're doing, the same exact thing with just closely spaced T's. That's why it's important to make sure that you size your closely spaced T's correctly. And it's always 4 times the pipe diameter, and you'll see in our manual, it shows you up to 12 inches. That doesn't mean 12 inches apart. That means that your maximum distance is 12 inches apart, and that's most likely you're using 3-inch pipe. But low loss headers and closely spaced T's are doing pretty much the same thing. They're doing that system separation. This is just showing you one that's a closely spaced T that you can buy. These Webstones here that now they have them in ProPress as well. This was just one customer that we came to the class, and he showed us how to make, how he's showing his guys how to make his closely spaced T's as well as soldering. You'll find that most likely low loss headers are going to be easier and more beneficial for you as well. The nice thing about these Webstones here is if you lose your pump in your system, you can close that valve and use the pump and maybe get a little heat through there to activate your house a little heat-wise. So here's how that closely spaced T's, if you took that low loss header out, it would be doing the same thing with closely spaced T's. Not quite as engineered for that, but it's doing pretty much the same exact thing with your closely spaced T's. So you're separating your system from your boiler side. Hopefully that explained it.
All right, awesome. Well, it looks like that is all the questions, Jay.
Oh, awesome. Well, thank you everybody for attending today's webinar. I appreciate you spending time with me on our days are getting a little boring here and there as far as you can't go to work and come home and get away from work. So you're working from home, but hopefully you're all contractors and you're still able to work and make money. Just make sure we keep our distances and stay healthy and stay safe, and hope to see you in the future face to face. And again, thanks a lot. And here you go, Miranda.
Thank you, Jay. Just a reminder, this will be up in the next week or so in the video library. If you have any additional questions, feel free to email me. We will be putting together a Q&A spreadsheet and we'll send out to everyone that's attending today. Lastly, you will be receiving a follow-up email. We ask that you please take the time to fill out the quick survey to help us further improve our webinars, as well as pick the next topics we will offer. With that being said, that concludes our webinar today. Thank you for attending and have a wonderful day.